Okay, so this is again, and now we're going to once again look at the this is going to look at the finals in these contacts. We'll talk a little bit about the edge contact, and we'll talk a little bit more about it later, but this is to use the compare. And so what we had before is we were counting time, and what I'm going to do is I'm going to keep that, I'm going to make that at 1,000 milliseconds, and that's so we can see it count. Now what I'm going to do is I'm going to count this one, and we're going to have this to be a tank fill, and we're going to fill up this tank. Well, we're going to fill it up and down, so I need to change that to an up-down counter, and the set point will be 200. It should never reach there, but that's what we're going to have. This second one I'm going to delete. These blink timers we can leave in there as is. So we're going to use some compare as we fill it up. And I think it potentially can fill up between 0 and 200, but really what we're going to try to do is we're going to try to drain it. Well, we'll fill it up. We'll drain it at 175, and then it'll drain down, 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 and then we'll fill it up again when it gets to 25. So we'll use comparisons to set up when we're draining or filling. And we need to add some rungs, and I'll add them right after the counter. Yeah, that'll be fine. So I'm adding rungs after the cursor, and I have to do this several times. And I think I'm going to need a couple compares, and then I've got to make a couple latches. So I'm going to add 4 rungs in here. Okay, so, and also while I'm looking at this, I don't need to recycle this, so I'm going to delete that. And for over here, I'm going to use my line erase function. Okay, so in here, when do I want to do comparison? I'll put in normally open, and I'll put in the C2 start process, and I want to be down here when I do it. So I'm going to put in C2 down here. And my first comparison, I'll do it for when we're filling. So we said we're going to fill when we're starting. Well, what we want to do is we want to do the fill set point when we're less than 25 gallons. So when this is less than 25 gallons, we want to go into the fill mode. So we're going into the compare, and all our comparisons are going to be to this number here. This is the running number of our counter. So everything is going to be running off CTD1. And here we're going to say, and I'll use less than or equal to 25. So when it hits 25, we want to go into the fill mode. So over here on the output, I'm going to put a bit. And let's take a look at what we have available. So I did put in these fill bits. And there's difference. We have bits, and then we have tanks. And the tank and fill tank and drain tank are actually what we're going to use into our counter. So I'm going to put a fill bit over here, and that'll be fine. And now I want to do the same thing, so I'm going to kind of copy this, and I'm going to paste this down here. But now I'm going to say when this is, I'm going to say when it's greater or equal to 175 gallons. Now I want to go into my drain mode. So I'm going to change this bit, and I have a drain bit set up too. So that's my fill bit. That's my drain tank bit. Now, why am I just using bits here? So when this goes high, this will go into fill, but what happens here is, for instance here, when it's less than 25, it'll say, okay, you need to fill. So when it's less than 25, this will go high. But as soon as it goes higher than 25, it'll go low again. So what we have to do is we have to take this bit, and what I'll do is I'll put it over here as a normally open contact. And this will be C8. And that's okay. Now over here for my output, I'm going to put this on, and this will be my actual fill bit, fill tank. So this is fill tank. And I'm going to do our normal latch-in seal-in circuit, so I'm going to add a row afterwards. And I seal in my output, so this is going to be C9 for the fill bit, or the fill tank. Now what's going to unlatch it is when I see my drain tank bit. So C7, when that goes high, we want to interrupt this circuit. So I need a normally closed contact, and that will be C7. Okay, and I'm going to line that up with going in here, edit mode, line mode, and I'm going to connect that. Now I've got to do the same thing for the drain tank, so I'm just going to copy this, paste it, and then change all the addresses. So I'm going to take my drain tank bit, which is C7. So C7 there. And now my fill tank bit is going to be C8. So I'm going to make that one C8. Now I just have to find out which is my drain tank bit. And my drain tank bit will be C10. So I'll put C10 there, and I know that I'm latching that in, so this will be another C10. So that should be what we have for setting up our latching circuits. Now when I go into this, when am I counting up? So I'm still going to be counting when I see T1, and instead of that being, well, that's going to be, I need to change that to a normally open contact. And the contact that I want is going to be my fill tank bit. So that is this bit. Okay, so when that bit is high, this will be filling all the time. And I'm going to do the similar thing down here, so I need 3 normally open contacts. So I'm going to put one here, and that'll be C2, my start process. My second one will be T1. And that's not got the right name. And my third one is going to be, now this will be my drain tank bit, which we decided was C10. Okay, and I'm just going to go into my line, and I'll go over here. Now, what do I want? So that second timer is wrong, and this one has a wrong name too. So I'll go into my T1. Well, CT1 first, because I'm highlighted there. That's why I go into C1. Instead of it being, I'm going to call this my tank fill level. Okay, and that's a better name for it, and I'm okay with that. Now I want to go into here and change this one in the address picker too. And it's not seconds. I think, well, I'll just call it a flow timer, because we're filling up the tank with presumably some type of liquid, so there is some flow involved. So it's just a timer that's going to simulate flow. So my names are at least better. So let's take a look at what we've got so far. We've got the normal thing. It'll go red here. It'll start counting at 1 second intervals. When that times out, we're going to count, depending on whether it's fill or drain, is we're going to count up or down. We've got the reset, and so this is not start process. The output, the CTD, will be automatically set to 1. When we're less than or equal to 25, we're filling. When we're greater than 75, we're draining. And we have latching bits for drain and for fill. Okay, so now what do we want to do with the lights? So I want to have my yellow light on when it's a low level. And what I'm going to say, so I'm not going to set it right for 25. I'm going to set it higher so we can actually see it do something. So I am going to say for my yellow lamp, when we're in start process, and anytime my level, because I want to use more compare instructions, I'm going to say anytime it is, well, CTD1 again, anytime it is less than or equal to 40, okay, I am going to have my yellow lamp on. So we've got to be in start process, and anytime it's less than 40, it's going to be yellow. So when we initially start up, it's going to be at 0, and we said it's going to be at 0 just because we set it there, and it's going to be yellow until we get to 40. Now for our green lamp is normal condition, so I'm going to have green between 40, when it goes above 40, and until it gets to our high level, which I am going to turn on the red lamp at 160. So this one, I'll get rid of that guy, and I'm going to get rid of this guy. So our green lamp will be on, let's see, with compare. Now this is going to be an AND compare. I'm going to have to put two of them back to back. So this is going to be anytime it's greater than 40, and I'm going to put another compare in here anytime our CTD1 is less than 160. So both of those have to be true for the green lamp to be on. So it has to be greater than 40 and less than 160. Now, for my red lamp, I'm going to use these timers, okay? And for my timers, so this timer I'm also not going to enable unless it's greater or equal to 160. So I have to put a compare in here too. So again, it'll be CTD1, and now it'll be greater or equal to 160. And that'll start this timer process, and then it'll be timing. So I am going to have my red light blink when it's at a high level, because that's kind of where we're getting near overflow, and we only have 3 lamps, so we got to figure out something to do with it. So we can't put the red lamp down here, because up here we already have the red lamp up here, and you never put an output in 2 different spots. If we need to control it from different places, we will put a separate branch circuit underneath. So I want to add a row. And now here, it's red when it's not running. Here, what we're going to do to start off, we'll make sure that it is running. So it'll be C2. And we're going to put in our compare, because we want to make sure that it is CTD1. And we want to make sure it is greater to or equal to 160. So that has to be true. And what else has to be true? So in our timers down here, we decided last time, so we've got a T2. And when this is counting, this will be off. When this is counting, it'll be on. So we can say T2 is what we want. So we're going to put a normally open contact, and that's going to be T2. And we're going to line that up. Edit, line, connected up. And let's take a quick look at what we've got. So we've got the normal start process. When we're not in start process, we're in red. Or when we are in start process, the level is greater than 160 and we have that blink timer is on, we're going to have a red, and it'll be blinking when it's greater than 160. So then we have start process. We're going to just continuously run our counter, and this will reset it. Now every time it counts up to 1 second, it'll either be counting for filling, and it'll start out counting for filling. So it'll start at 0 and it'll go all the way up to 175, and then from there on it'll go down to 25 and back up to 175. And that's all this is going to do. Just keep going back and forth, back and forth. Here we can reset it with the push button, or when we're not on it, it'll be reset to 0, and that's fine. Now, when we are less than or equal to 25, we're going to say that's when we're filling. And when we're greater than 175, That's when we're draining. And here we're going to latch it. So this will go high when it's equal, less than or equal to that. And this is going to latch it until, so it's going to latch at 25. At 25 is where it turns on. It's going to stay on until this goes high when it equal to or greater than 175. And then it's the opposite here. When we get to 175, it's going to say drain, and this bit is going to be on until we get to equal or less than 25. Now, these are our blink counters, and we want to make sure that the only time they start blinking is when it's greater than 160. And here, our yellow is going to be on at 40. So when it's any time in normal operation, between 40 and 25 we'll have yellow. So that's saying, hey, you're getting low. And between 40 and 160 it'll be green to say that's normal. And greater than 160, greater or equal to 160 is when we're turning on a red lamp. And I'm not sure that I need this statement in both places. I think I just need it here because otherwise the timer wouldn't blink. But we'll leave it where it is right now. And then the last statement is I do have to recycle these timers, and we do it when T2 and T3 are both high. So let's see. Let's take one last look going in the other direction. And yeah, I think that's right. We'll have to find out. So what I'm going to do is write the project in there. And it's kind of hard to see if that's yellow or red or both of them actually, but it is red only. And now they're off. And now it's just going to be red on again. And again, we can see red's on there, and we can see yellow and green are off. So let's, and what we want to do is we want to take a look at this one. And we're going to want to see that this is going to be fill initially, so we want to see this count up. And when we first turn it on, the yellow lamp is going to be on. So our yellow lamp's on, and we are counting up. And when we get up to 40 is when it's going to go from yellow to green. And here you can actually, last time we did it, you couldn't see it count, but it's counting. And the numbers you're seeing kind of jump, but you're seeing it, what the change is between scan and scan. And so that's what we have. So pretty soon we're at about 30. And you can see that these aren't high because these are just, it's in that normal position. And it's only going to be high temporarily, but we're going to latch it. So we're at 37, 38, and now we should go green. And we are green. And we're going to stay green all the way up until 160. And when we get beyond 160, if I have, the only question is if I have this guy set up correctly, is we should, green will go out and then our red will start blinking. So we've got a little ways to go here. But, you can see, you can kind of develop whatever type of program you want, and this is kind of unrelated to what we've been doing, but we say, well, let's just simulate a tank. And we have some, we've got the stack light, so we can put in different compare values, and you can see that we need a bunch of different compare values in a bunch of different places to make this work. And if you're looking at actual systems, a lot of times when you're using counters, you're using compare values. That is just the way it works. For instance, you might have it do something when it's at half full, and in fact if it got to say when we're draining and when it gets to 175, but if it got up to 190, that would mean that something's gone wrong in our program, and you could put in an alarm that would just shut down the whole system. So we could have another circuit that if we had it when it got greater than 190 for whatever reason, then we would just shut off our start process, because that would mean, if this were an actual tank, that would mean that, hey, you're most likely ready to overflow right now. So we're getting pretty close. At 160 is when it should start blinking red, and it'll stay that way until we get to 175, and then we'll start draining. So here's where we're going, and that I guess it's really hard to see on this webcam, but it is, well, it's obviously blinking, but pretty soon we'll be at 175, and then it'll go from fill to drain at that point, and it'll just switch right away. And now we're draining. You can see that the number is going down right here. And again, once we get below 160, it'll be green, and we'll stay that way, and we'll just let it go all the way down, and we can just verify that when we do indeed get back down to 25, it switches back to the fill tank. And if it does that for one cycle, I'm fairly confident that it's going to work forever. Well, so long as our PLC holds out. But you think about where we need all these compare instructions, and once you start putting in compare instructions, you can have it do different events at different values, but you can do a lot more with your project. And again, this is one of these things that you can kind of just design your own and create your own project. So and especially when you get further involved and we start talking about the HMI functions, you can visually put this on your screen. And we'll have other functions where you can change parameters. So you say, well, I don't like this happening at 160. I need to have it happen at 150. There are ways that you can easily program that from the screen. And when we eventually get there, we'll show you. But what we want to do is we want to see that when we get to 40, and we've got just a little over half a minute to go, that the yellow lights, the green light's going out, the yellow light's going to come on. And then what we want to do is we want to see that it's going to be yellow all the way down as we're seeing this count. It'll be yellow from 40, but the key is we want to see that when it gets to 25, it'll flip from draining the tank to filling the tank. The yellow light, it's a nice little thing to make sure that the circuit's working, but what really needs to happen is when it gets down to 25, we need to go from draining the tank to filling the tank. That is the key thing that needs to happen. So here our yellow light just went on and the green light went off, and that's what we expected to have happen. And we'll take a look at what happens here in about 5 seconds and just make sure that we flip into the fill mode, and we did. And now you can see that the circuit is now filling up the tank again, and once we get beyond 40, I guess we'll just wrap this up because it'll look pretty good if it turns green. And there we go. So it's green, and that's an example of what we can do with comparators. And again, comparators are used all the time. When we get this comparator, we're going to use our seal-in circuit, and our seal-in circuit is invaluable for when we want to hold it, because this condition, it's only here temporarily and then it goes away, but we have to latch it in, we have to seal it in. So we have comparators and they work with the seal-in circuits. So that's our little discussion with the I didn't talk too much about the edge contacts, but we'll get to them eventually. They're kind of important, and they're pretty important when you're using in seal-in circuits. That is more advanced for when you're talking about industrial applications. But when we get to talking about linear actuators and whatnot, we will talk to it because it is a requirement when we're dealing with our stepper motor and control the stepper motor. So I think we bypassed that here, but we'll get into it eventually. So thanks. I know this is a long one, but there's a lot to cover with this one. So we'll see you next time.